pleasant day to each and everyone. Are you feeling okay today? Are you ready to learn something? Today, let us continue our lesson. We all know that numbers are very universal, and with it note, it can be written in different forms. Last week, we have discussed on how to transcribe decimal numerals into Egyptian, Babylonian, and Greek Attic numerals. Today, we will be fascinated all about transcribing decimal numbers into Chinese, binary, and hexadecimal numerals. From familiar decimal numbers that we use every day to Chinese numerals that carries history in China, the binary digits that power computers, and the hexadecimal that is used in enhancing security in website and computers. Now, you know and learn how each number transforms across these fascinating numerical worlds. Are you ready? Because I am ready. Now, let us begin. Let us transcribe numbers. First, let us transcribe decimal numbers to Chinese numerals. These are the Chinese numerals, the numbers that are used in what country? Of course, it is China. The Chinese numerals are used in their everyday lives, in their trades, in their astronomical beliefs, and on how they are interacting with others using numbers. These are the numbers that they have used. Let us now begin in transcribing numbers. For example, we are being asked on transcribing number 64 into Chinese numerals. Notice that it is these values. From 1 to 10, these are the symbols. You will know later on what these symbols mean. But first, let us have the lesser numbers. 64. How would we write 64 in Chinese numerals? What is the value of 6? Of course, it is the liu. Let us put the value of liu in here. Well, we have to draw it. Liu. And since it is 60, we have 6. And what number that we have to multiply so it will become 60? Of course, it is the number 10. So we will write the number 10 here beside itself. It is she. Then, let us now transcribe number 4. What is the value of 4 in the Chinese numerals? Okay, it is the C. Let us draw the C beside the she. It is like a window. This. And how do we read this number in English? It is 64. But now, how do we read it in the Chinese number? We will read it on what these numbers are. The symbol is Liu, so we will write the Liu. The next number is the value 10, Shi. And the last one is the 4, which is the C. So the number 64 in the China is called Liu Shi Si. This is the answer. Did you get it right? Now, I will give you some number and please do it on your paper. Can you transcribe the number 86? Try this. Did you get it right? If yes, then good. Okay, let us now move on to numbers where it is 3 digits. I am thinking of a number 151. Okay, so notice that number 100 is not here. Okay, the number 100 is this. This is the value of 100 in China. It is called Bai. Okay, now let us begin transcribing 151 to Chinese numerals. 100 is Bai, but what is the value of 1 in here? It is the Yi, the one stroke line horizontally. We will write the Yi. And what number that we will multiply to 1 that it become 100? Of course, the 100 itself. So let us draw the symbol of Bai, or the symbol of 100 in China. Yi Bai. It is like a cabinet. Bai. And now, we are done with the 100. Now let us move on to number 51. Just like we did earlier, we will find the value of 5 in Chinese numerals. So 5 is Wu. Let us draw the Wu number. This is the Wu. And what number that we will multiply to the number 5 so it will become 50? Yes, it is the Shi, or the number 10. Let us draw the Shi. And now, what number is lacking? The number 1. So, what is the value of the Chinese numerals? It is the Yi. And we will write the Yi. So this is the final 151 in China. So how we will read it? The 151 is being, we all know that 151 is 151 in English. But how would we read it into China, or the Chinese numerals? It is, what is this called? The Yi. And this, the Bai. How about this? This is the Wu. And this is the Shi. And this is the Yi. So the 151 151 is Yi Bai Wu Shi Yi in China. Did you get it right? Or did you understand it? Now, do it on your own. Transcribe number 149 on your own. If you get it, then that is good. Now, let us move on to the 4-digit number. This is the digit for 1,000. Okay, let us think of a number on a decimal number that is 4-digit. I am thinking of a number 1, 4, 3, or let us have it 2,143. Okay. The number is 2. What will we find here? Of course, the number 2. Next is it is 1,000 or in the 1,000 place. So let us add the number Qian. Next is the number 100. 1 is Yi. 100 is Bai. So we already have 2,143. So 4 is C, the window one. Like that. And what number that we will multiply to the C to make it number 10? So the 10 itself. The symbol is Shi. It is like a cross. Then the 3 is San. So this is the number 2,143 in China. This is written on this form. So how will we read it? 2,143 is called Qian Yi Bai Si Shi San. So the 2,143 is called Qian Yi Bai Si Shi San in China. Did you get it? Now, do it on your own. Transcribe the number 5,432 in your paper. If you get it, then you are almost good. Because we are not done yet. Let us now move on to the 5-digit or the 10,000th place. So this is the 10,000 value in the Chinese numerals. Just like you keep asking in class about how to transcribe 99,999 in Egyptian. You keep asking me that. And now let us transcribe it into Chinese numerals. 9,999. 99,999. Now, do you know that it is the easiest number that can be transcribed here in Chinese numerals. Why? Because almost all of the digits are the same. So what should we do? 99. Let us first go to the 90,000. What is the value of the 9 here? It is the Jew. We'll have to draw the Jew. Okay. It is like a pie symbol. Jew. And the 10,000 is 1. This symbol. 1. And the 9 again, you'll just have to copy what you have drawn in there. And the thousands is the Qian here. The Qian. Next, 9 again. We'll just have to draw the 9. That's why I said it is almost the most easiest. 9 again, and next is the 100 sign, which is the buy, the cabinet 1. Now, it is 9 again, we'll know that. Next is the value of 10, she. And then, the value of 9. So this is the 99,999 in Chinese numerals. So how will you read it in China? The word that will keep being repeated is the Jew. Okay, Jew. And what is the 10,000 called in Chinese numerals? It is the 1. Jew 1, Jew, Qian, Jew, Bai, Jew, she, Jew. So this is the reading of the 99,999 in Chinese. The Jew 1, Jew Qian, Jew Bai, Jew Shi, Jew. Did you get it? Okay, now do it on your own. The value is 88,912. If you get this, then you are doing great. Did you get the transcribing of the Chinese numerals? Okay. Now let us move on to the binary digits. From the word itself, binary. Bi, which means 2. There are only 2 numbers that are being used here in binary digits. These numbers are 0 and 1. Maybe you all know or familiarize these numbers because these are commonly found in computers. There are 2 ways on how to transcribe decimal numbers into binary numbers. These are the subtraction and the successive division. Let us first do the subtraction. Or before I start, at the end of this video, you'll be able to, or at the end of this lesson, the binary lesson, you'll be able to distinguish on what is the most easy way, the subtraction or the successive division. Let us first start on the subtraction. Let's think of a number. the number 30. How will we make the number 30 into these numbers? Let us always remember, if we use subtraction, let us memorize or remember the power of 2. The power of 2 is 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, power of 4, and so on. There are a lot of numbers. It is infinite. Okay, so the value of 2 raised to the power of 0 is number 1. It is the law of integers that if the exponent is 0, even if what number is on the base, it is always 1. It is always equal to 1. So 1 is 2 raised to the power of 0, 2 raised to the power of 1 is 2, and 2 raised to the power of 2 or 2 squared is 4. 2 raised to the power of 3 or 2 cubed is 8, and 2 raised to the power of 4 is 16. Notice that if these numbers are not almost greater or less than, we have to continue. Okay, let us find out what is 2 raised to the power of 5. So 2 times 2 times 2 times 2 times 2 is equal to 32. So did we get it? 32 is greater than 30. So let us stop here. The number that we will use is lesser than 30. So these numbers, where is lesser than 30? The number 16. So these numbers is what we will going to use. Since we are using subtraction method, we will subtract number 30 to the number that is lesser, number 16. We'll put number 16 here, and 30 minus 16 is equal to number 14. Find the lesser number here of the number 14, the number 8 minus 8. The lesser number is number 8, and 14 minus 8 is 6. We will write the number 8, this number here, plus 8. 6, find the lesser number here. It is the number 4. Okay. We will minus the number 4 here and add it above number 4. 6 minus 4 is equal to 2. And since there is a 2, then let's add 2 here and subtract it here, and we'll get 0. So why did we add it above what we have subtracted? So the reason is, let us add all together. 16 plus 8 is equal to 24. Plus 4 is equal to 28. Plus 2 is equal to 30. So that is the reason, because if ever that these do not match with the number that is given, then what are you doing below is wrong. Okay, since we got the 0, let us stop. So, how to turn this into a binary number? Do we have the number 16 on what we have added? Yes. So we will put number 1. Number 8. Yes, 1. Number 4 is, yes, we have number 4. So we will put number 1. And number 2, we have number 2. And number 1, we do not have number 1 here, right? So we will put the number 0. So this is the value of the number 30 in binary number using subtraction. Let us put it here. Subtraction is, we get 1 1 1 1 0. This is the binary number for the value of 30. Okay. Let us now do the successive division using the same number, number 30. Let us find out if we will be able to transcribe it to this number also. The number is 30. In successive division, there is no need to memorize these. So, 30. Since we use division, what we are going to do is to divide. And since it is binary, and binary is equivalent to 2, we will divide all of number into 2. Okay, 30 divided by 2 is equal to 15. Are there any remainder on 30 divided by 2? Okay, there is none. So we will write R 0 because there is no remainder. Now, we will divide the answer to number 2. As I said earlier, we will divide all of the number into 2. 15 divided by 2, you can use calculator. But if it is these numbers, it is easy because it is small. So 15 divided by 2 is 7.5. So 15 divided by 2 is 7. And there is a remainder. If there is a remainder, then we will just have to put 1. If there is any. If there is none, we'll put 0. Okay. The number 7, we will going to divide it to 2. 7 divided by 2 is equal to 3.5. So there is a remainder. Remainder 1. Then 3 divided by 2 is equal to 1.5. There is a remainder. So we will have to put 1. And 1 divided by 2, because we do not have the 0 answer. So we will have to keep going. 1 divided by 2 is equal to 0, but there is a 0.5. So we will have to put 1 again. So since we already got the answer 0, we'll have to stop. To get the answer of this number using the successive division, it is from MSB to the LSB, or the most significant bit. It is the MSB, or the most significant bit, to the LSB, or the least significant bit. Okay, MSB means that this position holds the highest value. So of course, if we write this, it would be equal to 1, 1, 1, 1, 0. So does the answer in the subtraction method and the successive division the same? Yes, it is right. So I'll ask you, what was the easiest way? The subtraction or the successive division? Now, let's move on to the hexadecimal numerals. How are we going to transcribe decimal numbers to hexadecimal numerals? Know that this is the decimal numbers and we will turn it into hexadecimal. From the word hexadecimal, decimal, we all know means that it means number 10, from the word deci, or 10, plus the word hexa, or the hex, which means 6. So if the decimal numbers are up to 10, are base 10, then the hexadecimal is base 16. So from 0 to 15, these are all 16 numbers. So what is the value of these numbers? Since we say earlier that hexadecimal is base 16, so what is the value of these numbers? 0 is equal to 0. From 0 to 9, or the base 10, because hexadecimal. So the base 10 is equivalent to itself. But since it is hexadecimal, we need to add numbers. So there are 6 remaining numbers here. 1, 2, 3, 4, 5, 6. The value of these numbers are different from these. Why? Because if we put 10 here, it will be redundant, or it will repeat. So it is a no. What we are going to use is the letters of the alphabet. A, B, C, D, E, F. These are the hexadecimal numbers. So if we are going to be asked, how will we going to transcribe bigger numbers to hexadecimal numerals? Let us try. 430. This is a base 10, right? Because it doesn't transcribe to hexadecimal numerals yet. So we'll put sub 10 here, so we will know that it is a decimal. Since our topic is all about transcribing decimal numbers to hexadecimal numbers. How are we going to transcribe this? It is the same on what we have did earlier in the successive division. But since in the successive division, it is binary, we divide all the numbers by 2. But right now, we're going to divide the numbers by 16. So 430 divided by 16 is equal to, you can use calculator on your home. I have here a calculator. Since it is big number, so we need a calculator for us to do it easily. 430 divided by 16 is equal to 26.875. So you'll write it here. Remainder. So there is a remainder, but it is too large. So how are we going to make it the same as the binary process? What we are going to do is multiply the decimal or the remainder to number 16. We will multiply it. Let us try. 0.875 multiplied by 16 is equal to 14. So we will write the 14 on the remainder. Why did we put number 14 here? So you will know at the end of this session. So just like binary, we have to divide the 26 by 16. 26 divided by 16 is equal to 1.625. We will write 1.625. And the next step is to divide the decimal point to the number 16. 0.625 times 16. We will put the remainder then here. So, did we get the number 0? No. So, we will keep going. 1 divided by 16 is equal to 0.0625. So we will stop because we got the number 0. The next step is to multiply the decimal point to the number 16. 0.065 times 16 equals 1.04. So we will only copy the 1. So this is done. How are we going to write it into hexadecimal numerals? So we all know that hexadecimal numerals are this. Just like the binary, the MSB is here, or the most significant bit, and the LSB is here. So the highest significant value is on this position. We will write it as 11014, but Notice that number 1 is redundant. So what are we going to do? Use these numbers and letters. So 1 is equal to 1. 10 is equal to A. And 14 is equal to E. So the value of 430 and hexadecimal numerals is 1A E. So we will going to put 16 here because it is the hexadecimal numerals. So the decimal numeral 430 is equivalent to 1AE in hexadecimal numerals. Did you get it? Can you please try the number 459? Do it on your own. Did you get it? Okay. Let us try bigger numbers. I'm thinking of a number 800,001. This is a decimal number, so we're going to put sub 10 base 10. The first step is to divide it to 16. 801 divided by 16 is equal to, use your calculator, 50,000.0625. So we'll write it here. 50,000.0625. We will multiply it as we did earlier to the number 16. .0625 times 16 is equal to 1. So we'll put remainder 1. Next step is to divide the base into 60. 50,000 divided by 16 is equal to 50,000 divided by 16 is equal to 3,125. And there is no remainder, so 0. We will write there remainder 0. Again, why don't we multiply here? Because if we multiply any number by 0, it will always equal to 0. Okay, move on. 3,125 divided by 16 is equal to 1,000. No, it is 195.3125. 195.3125. Next step is to multiply the decimal point to the number 16. 0.3125 times 16 is equal to 5. So remainder 5. Next step, so on, 195 divided by 16 is equal to 12.1875. 0.1875 multiplied by 16 is equal to 3. So we will write remainder 3. Go on because we do not have the 0 yet. So 12 divided by 16 is equal to 0.75. We did get the 0, so we will stop. So the next thing we do is to multiply 0.75 to number 16. It is remainder 12 because we get that number 12 here. As we did earlier, we will write it upward from MSB to LSB. 12 is equivalent to the letter C. 3 equivalent to itself. Also 5, 0, and 1. So the value of 801 in hexadecimal numerals is C3501 base 16. So this is the hexadecimal numerals for 800,001. You may notice that it is like a PIN or the OTP that a computer or website has sent us, because it is the primarily use of this numerals to keep security on cell phones, on website, to strengthen it. So these numerals are made. I hope you learned something for today's lesson. Goodbye and keep safe.